Hello students, this is Photon Academy of Science. In this video lecture, we are studying about equation of rotational motion, same as equation of motion. Okay, equation of motion works for normal motion as uniform motion, non-uniform motion, but rotational motion works for rigid body. So now we start to determine equation of rotational motion. Here for rotational motion, first equation of rotational motion. Let omega naught equals to initial velocity omega equals to final velocity. In normal motion we use u for initial velocity and v for final velocity. Okay, t equals to a time taken. In normal motion we use as for displacement, but here we use theta as the angular displacement. In normal motion we use a for acceleration, but here we use alpha for angular acceleration. Okay students, the above descriptions are common for all three equations of rotational motion. For first equation, since we know that acceleration equals to change in velocity upon time, change in velocity upon time, but here we get angular acceleration, so here we also get angular velocity. We denote angular acceleration by alpha. Change in angular velocity means initial angular velocity minus final angular velocity minus initial angular velocity upon time taken. Here final velocity equals to omega and initial angular velocity equals to omega naught. So here we take 1 in denominator. Now we are doing cross multiplication. Omega minus omega naught 1 ja omega minus omega naught and alpha 2t alpha t. Now omega equals to minus omega transfer in RHS and becomes plus omega naught plus alpha t. So students, omega equals to omega naught plus alpha t is first equation of rotational motion. Okay, now we are solving second equation of rotational motion. Now student, we can give same description. Okay, in second equation of rotational motion, students, here we take formula of velocity equals to displacement upon time. Now we take 1 in denominator, displacement 1 ja displacement, and velocity into time equals to velocity into time. So students, here we are using angular displacement, not displacement, and angular velocity, not normal velocity. So angular displacement is theta, angular velocity here only we are writing about angular velocity, but here we are taking both velocities, initial angular velocity and final angular velocity. So we include average of both angular velocities, initial angular velocity plus final angular velocity by 2, average form, and we denote t for time. Now since omega equals to omega naught plus alpha t, first equation of motion, rotational motion, omega equals to omega naught plus alpha t. Okay students, now we put the value of omega in above equation. So theta equals to omega naught plus omega naught plus alpha t upon 2 into t, then theta equals to omega naught 2 omega naught plus alpha t upon 2 divided by 2 into t. Now students, theta equals to omega naught by 2 plus alpha t by 2 into t. So 2 to 2 cancel, to theta equals to omega naught plus alpha t by 2 into t. Now we multiply t in bracket and theta becomes omega naught t plus half alpha t square. Okay students, that is second equation of rotational motion. Now we are solving third equation of rotational motion. For third equation of rotational motion, the description are same, but here we are writing third equation. Okay, the description is same. Now we solve third equation of rotational motion by same formula, angular displacement equals to angular velocity into time. Since from previous question, angular displacement equals to angular velocity into time. Angular displacement is theta, angular velocity, we are taking here angular velocity in average form, omega plus omega naught by 2 into time t. Since by first equation of rotation motion omega equals to omega naught plus alpha t, now we find the value of t. So omega equals to omega naught plus alpha t, omega plus omega transfer here in LHS and becomes minus omega naught alpha t. Now t equals to omega minus omega naught, we transfer alpha from into to divide. Here we can find the value of t. Now we put the value of t in equation 1. From equation 1, theta equals to omega plus omega naught by 2 and the value of t is omega minus omega naught by alpha. Okay students, in above we can find identity of a plus b, a minus b. Now a plus b, a minus b equals to a square minus b square upon, we multiply denominator to denominator, 2 into alpha equals to 2 alpha, omega square minus omega naught 1 ja, omega square minus omega naught 1 ja, omega square minus omega naught square. Now we multiply 2 alpha in theta, so it becomes 2 alpha theta. Then omega square equals to minus omega naught converts in plus omega naught plus 2 alpha theta. That is third equation of rotational motion. Okay students, so students, here your topics of rotational motions are completed.